Welcome to AP Podcast 15.4 on titrations. This is going to be a fantastic section because one of the things I like about this stuff is it requires you to think. Alright, you guys know that's all written on my wall, but I'm telling you, you're going to have some acids mixed with some bases. You're going to have some equilibrium. You're going to have some stoichiometry. There's pretty much everything you could possibly ever want to do in any kind of chemistry involved in titrations, and so it's going to be pretty interesting. It's going to make your brain hurt a little bit, but if you take it slow, you'll find that it's not too bad. So to do titrations, I've got to introduce you to this new unit, and this new unit is called a millimole. As soon as I find my pen, there we go. It's called a millimole, and basically it's just 1/1000th of a mole. Now, why we use the millimole is because if you think about the titrating that we do, we titrate in milliliters. Think about all the times we've titrated. We're always dropping in milliliters of stuff. We're not dropping in liters. So if we use the millimole, and we divide that by the milliliters, the milli cancels, right? And we're left with moles per liter, which is molarity. And so it's going to be very effective. Now, if you don't feel comfortable using it, you can always divide everything by 1,000 and use moles and liters and all that, but you'll find that it's a lot easier just to do it this way. Okay? Now, there's a couple terms, couple things we need to be aware of when we're doing these titrations. First of all, when you add the solution of a known concentration till the substance is consumed, we call that the equivalence point. All right? Now, for you guys that were in my class last year, when we're using the phenolphthalein, all right, when phenolphthalein turned pink or light pink, that's when we were at the equivalence point. That meant we had the same amount of acid and base, all right? And that's a big deal. And then as we're titrating, we will generate a titration curve that'll look something like this. And we've got pH over here, and we've got milliliters over here, and you'll get very familiar with these titration curves. And so let's get on to it. All right, we're going to start with an easy one. We're going to start with strong acids and strong bases. Now, the nice thing about this kind of titration is there's no equilibrium to deal with. So the calculations are fairly straightforward. It's basically just a stoichiometry. And since both of those dissociate completely, they're both strong, it's a pretty simple, straightforward titration. So what we're going to do is we're going to go ahead and look at the pH at all of these amounts, and I should say when we add these amounts of base. Actually, I think I have one more in here. I might have a 50. If I don't, no problem. But I think there's a 50 in there. And so we're going to look at what happens to the pH when that amount of stuff is added. So here we've got 50 mils of 0.2 molar nitric acid, and we're going to dump in 200 mils of 0.1 molar NaOH. And so we're going to work it out, do the stoichiometry, and I'll also plot it on the curve so you can see what it looks like. So hold on to your hats. Here we go. So let's look at, I just wrote out the reaction, what's going to happen. Now the reason I just have H plus and OH is because, again, what are we dealing with here? We're dealing with the strong acid and the strong base, so this is essentially our reaction, right? We're just going to make some water. So let's imagine that we've got, let me go back. Okay, so we've got this situation right here where we've got 0.2 molar nitric acid. So, let me go back. What's the What's the pH to that thing? Well, I'm losing my mind here. All right, what's the pH? Well, if I take the negative log of that, I get a pH of 0.699. All right, so I'm going to show you a titration curve real quick. This is for a strong acid, strong base. So right here at 0, we're at 0.06, or not 0.6, 0.699. Okay, so that's where we're starting out. All right, so now let's go back to here. Now what we're going to do is we're going to add 10 mils of NaOH. So I'm just going to, let's see, 10 mils of NaOH. Okay, I'm going to add that. All right, and what's the molarity of that NaOH? Well, if you looked on the sheet before, you'll see that it was 0.1 mole, right? So what I need to do is I need to figure out how many how many millimoles I have, right? So this is what I'm going to do. I'm going to take my 10 mils, I'm going to multiply it by my 0.1 mole, and I'm going to get 1 millimole. All right, 1 millimole. Pardon me, that should read mole per liter, right? Okay, so I get 1 millimole. Now, how much acid do I have? Well, let's look back here. I've got 50 mils of 0.2 molar nitric acid, right? So if I have 50 mils of 0.2 molar nitric acid, 50 mils times 0.2 moles per liter. All right, what do I get? I get 10 millimoles. So I've got 10 millimoles of acid, and I've got 1 millimole of base. All right. Now what's going to happen? Well, again, this is a 1-to-1 ratio, right? So this 1 millimole of OH is going to react with 1 millimole of H. So we're going to lose 1, right? We're going to lose 1. Okay. And so now, after that reaction, I'm going to change colors here. I've got 9 millimoles, right? And then, of course, I have 0 of the base. Are you with me? I've just did a little bit of stoichiometry. Now, the question is, what is the pH at this situation? All right, well, this is how you do it. I take my 9 millimoles, because what do I have to find pH, guys? I've got to find this concentration, right? So I've got my 9 millimoles, right? And how much volume do I have? Well, remember, we started out with 50 mils, and then now we have 10 mils. We've added. So I've got 60 milliliters. Now notice the millis cancel out, so this is kind of handy. And what I do is I get 0.15, which gives me a pH, if I take the negative log of that, of 0.82. All right, so it went up a little bit. Go to my titration curve. So at 10 right here, it's 0.82. Okay? So now let's go to the next one. I know this is tedious. Trust me, I've done these a lot. All right, so now I've got my 9 millimoles, and we're going to add another 10. In other words, we're having a total, we've added, let's see, we're going to have a total of 20 mils of NaOH. Okay? Now, I've already added 10, so here's another 10, right? So again, same kind of situation. I'm going to lose 1 millimole, right? I've got 1 millimole. Oops. Okay, and that's going to give me how many millimoles of hydrogen? I'm going to get 8 millimoles. Right, and then of course this is 0 again because I used all that up. Okay, so after I've added a total of 20, what's going to be my pH? Well, I've got 8 millimoles of H+. I've got 70 mils, right? This is the key. This bottom part is the key. This is one thing where students will mess up. They'll forget they got to add the total volume, right? And so when I work that out, I get 0.11, and the pH of that equals 0.982. All right? So then I go back to my titration curve. All right, at 20, I'm 0.982. Notice it's going up a little bit. You can see this line. Not very much, but it's going up. Okay, now we're going to add, let's see what we're adding here. We're adding 50 mils. Okay, so total I've added 50 mils of base. Now, I've got 8. 50 mils. If I put a 50 right there, I would be, well, actually, it's not 50, is it? It's 30. So that I'm gonna subtract 3 millimoles. Right? 3 millimoles. Okay, and again, I hope I haven't lost you, but remember, from 20 to 50 is 30, and 30 times 0.1 is 3, all right? So now how much acid do I have left? I've got 5. And you can see how this is becoming very tedious. So again, 5 millimoles. What's my total volume? 100 mils. All right, and that gives me 0.05, and that gives me a pH of 1.3. It's going up, which is what we would expect. Okay, so now here at 50, I've got 1.30. All right. And then now we're going to, let's see, we're going to add 100. So I've dumped in 100 mils of base. Now, how many millimoles is that? Remember, we're going from 50. We've already dumped in 50. We're dumping in another 50. So I'm adding another 5, right? So minus 5 millimoles. Minus 5 millimoles, right? And so what's my new volume of H? 0. Of course the OH is 0, right? Because we've used it all. And so without doing any math, we basically have a solution of water. And what's the pH of a solution of water? 7.0, all right? So I go to my curve, and here we are at 100. Boop, there it is. There's 7.0, right? All right, so there's 100. Moving on. Let's see. We're going to add a total of 150. So I'm adding 50 more, right? You enjoying this yet? Yeah, I figured. Okay. Now, at this point, how much we're subtracting, I guess we're not even subtracting 5. We're not. What we're doing is all we have in our solution is 5 millimoles of base, right? There's no more H+, and all it is 5 millimoles of base. And so now let's find the pH of that. 5 millimoles. Our total volume at this point is 200 mils. 200 mils. And that gives me a concentration of 0.025 molar. However, what is this? This is base, right, guys? So here's another place where students kind of have a hard time. That's base. So what's that a concentration of? It's concentration of OH, right? So you need to find the pH. Now, you can, of course, do it however you want. You can find the pOH and subtract that from 14. But typically, I would just go 1 times 10 to the minus 14th, right? Divided by, whoa. My number is 0.025, right? And that gives me, sorry about this, guys. I know this is getting all squished up. That gives me a value of 4.0 times 10 to the minus 13th. And that's H+, right? So then the pH, let me find another color to help you out. So the pH at this point is going to be 12.4. So then I go over to my curve and, oh, let's say, what was it? Let's say 150 is right about here, right? 150. And so here's my 12.4. Okay? So there's that. And then the very last one, if we wanted to do that, which I'm sure you don't, is this 200 mils. Again, all I would be doing is adding another 50 mils. That would make this right here. That would make this 10. This would be 250. I'd get a pH of like 12.6 or something, and then we'd be done. All right? I know this podcast was a little long, but it's a good start. The nice thing about acids and bases when they're strong is that there's no equilibrium. Of course, we'll save the equilibrium for the next time, and that's where it really gets hairy. So we'll practice a few of these in class, and see you next time.